Question 8 is questions about organic acids. Lactic acid is shown below as two functional groups. So we've got the carboxyl group here and we've got the OH group. Lactic acid reacts with bases and with many metals. An aqueous solution containing 1.125 grams of lactic acid is reacted with an excess of magnesium producing hydrogen gas. The excess magnesium is removed. The water is evaporated, leaving white solid A. Name the type of reaction of lactic acid with bases and metals. Okay, let's start with bases. So an acid and a base makes a salt and water. What name do you give to any reaction with an acid and a base? Quite simply, it's neutralization. They're not trying to catch you out. They're not trying to try and be clever. It's as simple as it sounds. Reaction with metals. An acid and a metal always makes a salt and hydrogen. So any acid-metal reactions are redox reactions. Okay, it's as simple as that. That's all they're looking for there. You've got to get them both right then for the 1 mark on that one. Go over the page, the next bit. Calculate the volume of hydrogen produced, measured at room temperature and pressure. Straightforward moles calculation. Let me bring lactic acid structure back in. Look at what we already know. So, we've got a mass of the lactic acid. I want to work out how much hydrogen is produced. Okay, we're going to need to think about a reacting ratio as well, just so we can make sure we account for that. Okay, so let's almost write an equation first of all. What are we going to get? So we're going to take our lactic acid, react that with magnesium. That's going to produce the salt there and hydrogen gas. Okay, now again, let's think about the reaction taking place and think about the ions that are forming. Magnesium forms a 2+ ion when it's in solution, when it forms an ionic substance. Now lactic acid, again, we've got COOH, so this is going to be a 1- charge. Therefore, the formula of this, you're going to need to have 2 of all of that carboxyl bit. So it means I'm going to need 2 of those. So I'm going to have a 2-to-1 reacting ratio on my lactic acid to my hydrogen. So it's important that I did the equation there to figure that out. Okay, there's nothing else indicating that you're not told a reacting ratio, so you can't ever assume it's 1-to-1. So there we go. We've got our reacting ratio is going to be 2-to-1. So I want to work out the number of moles of lactic acid. It's going to be the mass over the molar mass. So 1.125 grams is my mass. I need to work out my molar mass of lactic acid. Okay, let's do it from their diagram. So transpose your atoms on if you're worried about getting the right numbers. Okay, make sure you account for everything. So I've got 3 carbons at 12 each, 36. I've got 3 oxygens at 16 each, that's 48. And I've got 1, 2, 3, 4, 5, 6 hydrogens. Add them all together, you should get a molar mass of 90. So that means the number of moles of lactic acid is going to be 0.0125 moles. Ratio, moles to hydrogen, 2-to-1. So my moles of H2 is 0.0125 over 2. Okay, and I want volume, so what I'm going to do then is multiply this by 24,000. Okay, it doesn't specify centimeters cubed or decimeters cubed, so I would anticipate therefore that when you work this out, you give the units. Okay, if units aren't stated, then make sure you include them in your answer. All right, so 0.125 over 2 to compensate for the ratio, times about 24,000 will give me volume in centimeters cubed, and that comes out at 150 centimeters cubed. If you did times by 24, then it comes out at 0.15 decimeters cubed. So just be mindful. Very rarely do I see questions where they don't give the units on the answer line. More often than not, they're there, but watch out for it. If they're not there, it will expect you to put them in. Okay, ideally it would say give units on your answer, but it hasn't on this one. It's asking you, it's expecting you to spot that they're not on the answer line. Bit of a tricky one. An easy one to miss. If you miss the units, you only get 1 of the 2 marks. Bit harsh. Okay, the next part to this answer this question. So it's come as part 1. It should be part 3, I believe. What's the empirical formula of the white solid A? Okay, so you've got from the equation here, and you've got your chemical formula. Okay, so if you take this chemical formula, well, I've only got 1 mg, so I can't make this any simpler. That has got to be my empirical formula. So everything in the brackets is doubled. So if you look, 1, 2, there's 3 carbons, there's 3 oxygens, there's 3, 4, 5, there's 5 hydrogens there. Let's check that again. 3, 4, 5. Yeah, there's 5 hydrogens. Okay, so my empirical formula here is going to be C6 H 3, 4, 5 H10 O6 Mg.